Hello, geometry. So yay, we're in chapter 8, Pythagorean theorem. You definitely did this in middle school. So this part of this is going to be a review. We are going to make it a little bit harder than you did in middle school. So start out, if you didn't already, please pause and try these warm-up problems. Okay, so welcome back. So square root of 7 squared. So you did this in the video with Miss Speckle. But you're going to do square root of 7 times square root of 7, which is the square root of 49. And then she talked about how these are actually inverse functions. So the square root actually cancels with the squared in this case, and that's why you just get 7. Okay, these ones are a little bit harder. So you have a whole number with the radical, but you are going to do the same setup. So you do 2 square root of 3 times 2 square root of 3. And then, as she talked about, you can only multiply whole numbers or integers together, and then you can multiply the radicals together. So here I get 4 square root of 9. Okay, and then square root of 9 is 3, so 4 times 3 would be 12. Okay, last one here. So 5 root 2 times 5 root 2. I don't know why that freaked out. So 5 times 5 is 25. Root 2 times root 2 is root 4. 25 times, and then root 4 again is 2. So 25 times 2 is 50. Okay, Pythagorean theorem. Again, you've heard this before and seen it before and used it before, but we're just reviewing it and making it a little bit harder. So in a right triangle, so given you have a right triangle, then you would know that a squared plus b squared equals c squared. So in a sketch, you always have to have a right triangle. So you must know it's a right triangle. And then the legs are A and B, and the hypotenuse is C. Okay, so as I said, A and B are always the legs. Okay, and the legs are the ones attached to the right angle. And C is always the hypotenuse. Okay, other things you can look for in a picture, however, is that A and B are always shorter than C. So these are going to be the shorter sides. And the hypotenuse is always the longest. So those are things to keep in mind. So here we're going to try some of these. Find the length of the missing side in these triangles. Leave your answer as a reduced radical. So what we're going to start doing is practicing leaving it in this radical form if it's not a perfect square. Okay, so here we have the right angles here. The C value, another way you can look at it is the C value is always opposite the right angle. So that's another way to look to see which one is the hypotenuse. So this one's actually a little bit tricky because they put the variable A as the hypotenuse, but for the actual Pythagorean theorem, this is going to be C. And then A and B are actually interchangeable. So you really only need to label C when you start using the Pythagorean theorem. So in this case, I would write, so A squared and B squared. Again, I could write 3 squared first or 4 squared first. That part does not matter. So it's 3 squared plus 4 squared equals C squared. And this value is actually the C. So maybe I will call that A. Okay, it's the hypotenuse squared, which is by itself. So 3 squared is 9, 4 squared is 16, and that's equal to A squared in this picture. These add up to 25. Okay, and then to get a by itself, you do the inverse of squaring, which is square root. So I'm going to do square root. Now officially, it is plus or minus. You probably remember that from last year in algebra. But in geometry, a negative length does not make sense. So really, we're only going to talk about the positive version for geometry. But obviously, the square root of 25 is 5. So my final answer is A equals 5. Okay, next one. So here, again, you want to label, and I think that's a 9, not an A. This is the X. So what I would do is just label the hypotenuse. Here's the right angle. Across from there has to be the C. And again, the 4 and the X are interchangeable as A and B. So maybe I'll put the X squared first this time. So X squared plus 4 squared is equal to, I believe that's a 9. 9 squared. Okay, so simplify the squareds first. You can use a calculator too if you don't know that one. And now you have to get x squared by itself so that we can do that step of square rooting. So I'm going to subtract 16 from both sides. Okay, so minus 16, 81 minus 16 is 71 minus the 6, so 65. And then x squared, you're going to square root to get x by itself. Again, officially it is plus or minus the square root algebraically, but in geometry we only really look at the positive version for a length. Okay, so my final answer is x equals the square root of 65. Now, if there was a perfect square that divided into 65, we would reduce this as well, but this one should just stay square root of 65. Okay, next here, you're not going to change that to a decimal. So now we have, again, identifying that as C, but now we have a 5 root 2. Now, luckily, we did that above. We did that right here. So we're just going to use that. But 5 root 2 squared is going to be 50. And then 7 squared is 49. So now I'm skipping one of the steps. Equals x squared. Okay, add those together and you get 99 is equal to x squared. Okay, square root both sides. Officially it's plus or minus. And then 99 has a perfect square in it. So it is helpful if you write all of your perfect squares off to the side. So what do we have? 1. 1 doesn't really help us much, but 9, 16, 25, 36, 49, 64, 81, 100 are the popular ones. Again, perfect squares. Notice that 9 here divides into 99. So I'm going to change this to the square root of 9 times the square root of 11. And then square root of 9 is 3 times the square root of 11. So that would be my final answer for x. Okay, now the other thing you have is Pythagorean triples. So you can see right above here, this is considered a triple because all 3 side lengths are whole numbers. Okay, so what we have is 3, 4, 5 is a triple because 3 squared plus 4 squared equals 5 squared. You can do that for all of these triples, and there's actually an infinite number of these triples. But the popular ones are 3, 4, 5, 5, 12, 13, and then some ones that are sometimes used are here and here. This one's hardly ever used, but just realize there are some weird ones out there as well. Okay, So using those, the nice thing about triples is that you can use a triple and not have to show work if you notice it. So here, notice here we have, this is C, okay? And then if you look at your list above there, 5, 12, 13 is a triple. So you could just write the word triple and then say x equals 5. And then you're done, which is nice. Okay, these ones are not as obvious, but let me just note something for you. Any multiple of triples is also a triple. So 3, 4, 5 is 1, 6, 8, 10. So I just double those. If I multiply these by 3, I get 9, 12, 15. If I multiply by 4, I get 12, 16, 20. If I multiply by 5, I get 15, 20, 25. And you can keep going. So these are all triples as well. So if you look over here, this one is just 3, 4, 5 multiplied by 6. So this is 5 times 6. This is 4 times 6. So 3 times 6 would be 18. So again, this would be a triple. And C is 18. Okay, next one here, 16, 30, and then we have hypotenuse. Now this one, again, if you look at your list above there, 8, 15, 17 is a triple. This is just double that, 16, 30, and then if you double 17, it's 34. So this is also a triple, and S is 34. Okay, next thing we have is converse. So the converse of the Pythagorean theorem says, if I have this equation that's true of the side lengths, then I can conclude it's a right triangle. So we flipped the logic. You're given the side lengths and then concluding that it's a right triangle. Okay, other conclusions you can draw is if that c squared is smaller than a squared plus b squared, this is acute. And if that c squared is bigger than a squared plus b squared, then the triangle is obtuse. So in order to do this, notice there's no right angle here. You just have 3 side lengths, but the c value has to be the largest. So you're still going to identify the c value as the biggest. And then for these, I would recommend you write the c squared first. So I'm going to write 43 squared, and then 22 squared plus 36 squared. And then I'm going to figure out how these are related. Obviously, you probably want to use a calculator. So 43 times 43, or 43 squared, is 1849. 22 squared is 484. And 36 squared is 1296. Okay, so we're trying to figure out how these are related. All right, so now I'm going to add these two together. So 1296 plus the 484, sorry. So 1780. So what I have here is 1849, which is obviously bigger than 1780. And if it's bigger, it's obtuse. So this triangle is obtuse. And the next one here, so again, you identify the biggest. So this is my C, and I set up 85 squared. I'm going to figure out how they're related. And then I have 77 squared plus 36 squared. So pause and try to figure out that relationship. Okay, welcome back. So you have 85 squared is 7225, so 7,225. And then 77 squared plus the 36 squared is also 7225.